This is a gate problem on Venturimeters and it appeared in the Instrumentation Engineering paper. So this falls under the unit of Sensors and Industrial Instrumentation module. So the problem is stated as follows. The accompanying figure shows a vertical Venturimeter with upward water flow. When the measured static pressure difference P1 minus P2 between the inlet and the throat is 30 kilopascal, the flow rate is found to be 50 liter per second. Assume that the coefficient of discharge remains the same. Now, when P1 minus P2 equals to 20 kilopascal, the flow rate in liter per second is, four options are given. So this is an MCQ type question. The options are option A 33.3, option B 39.3, option C 40.8, and option D is 54.2. This is the diagrammatic representation of the Venturi tube. So it is understandable that this is the inlet section and then this is the diverging section or the outlet section, and in between we have the throat. So you take one measurement for the pressure drop over here and the other measurement for the pressure at this point. So this is the inlet point and the other one is right at the throat, and so the distance between these two, this is mentioned as 400 millimeter, and the pressure drop between these 2 points will be delta P, or in other words this is P1 minus P2. So P1 is the pressure at this position and P2 is the pressure at the throat. So the idea is very simple. For a question like this, all we have to do is to remember that the volumetric flow rate is directly proportional to the square root of delta P, where delta P is equal to P1 minus of P2, and the equality is given by the coefficient of discharge factor. Therefore, Q becomes equal to C sub D times square root of delta P. Now, referring back to the question, the information that we are given here is that the pressure drop is equal to 30 kilopascal and the flow rate is 50 liter per second. So we can easily substitute those values for Q and del P, and we can find out the value for coefficient of discharge. And then again, if we look back at the question, we find that the coefficient of discharge remains the same. So CD is constant. And therefore, if we are given some new value for delta P, as it is in this question, they have mentioned it to be 20 kilopascal. It is easy to find that Q should be equal to CD times square root of delta P, and in this case this is simply equal to 50 divided by square root of 30,000 multiplied by square root of 2000, and this is equal to 40.8 liter per second. So the key concept from this question is that we have to remember this particular equation, which is Q is equal to CD times square root of delta P.